By defining what Ka is, or the acid dissociation constant. Ka is the relative strength of an acid in solution. So if we take a molecule of HCl, we can see that it dissociates into H plus and Cl minus. To find the Ka, all you need to do is take the concentration of H plus times the concentration of Cl minus all over the concentration of HCl. But today, we're going to focus on what the pKa's of organic molecules are. To get the pKa, just apply the negative log of Ka. Now we found out how to calculate the pKa, we can say that the higher the pKa, the more basic a molecule is. The lower the pKa, the more acidic the molecule is. The molecule can be thought of as existing in two states, the protonated and deprotonated forms. The pKa of a carboxylic acid is 3 to 5. So what dictates what state the molecule is in is the pH. When the pH is at 2, the oxygen will be protonated. This is because the pKa is higher than the pH. Now, if the carboxylic acid is placed in a pH solution of 7, the oxygen will be deprotonated. This is because the pH is higher than the pKa.
So now that we found out how our molecule is affected by pH, unless you're testing each one of these molecules out in lab, there's just a general pKa table you might want to memorize, which is your carboxylic acids have a pKa from 3 to 5, your protonated amines have a pKa from 9 to 10, phenols have a pKa from 8 to 10, and alcohols have a pKa from 15 to 16. So what affects these different pKa's? The first thing we might want to look at is your resonance. So here we have a carboxylic acid and we have an alcohol. So in both cases we deprotonated your oxygen to be left with an O- and an O-. But in the case of the carboxylic acid, as you can see, we have these two lone pairs that can come in and kick this out and form this resonance structure. So the carboxylic acid is able to delocalize that negative charge where the alcohol cannot do that. So pKa gets lower when the conjugate base is more stable. Another thing we might want to look at now is electronegativity. So here we have a regular alcohol, an alcohol with 1 fluorine on it, and an alcohol with 2 fluorines on it. In both of these cases, case 2 and case 3, we have electron withdrawing groups. So what these electron withdrawing groups do, they make this OH bond weaker, which makes the molecule more acidic. So in these cases, the regular alcohol will have a higher pKa than the alcohol with 1 fluorine, and 1 fluorine will have a higher pKa than with 2 fluorines.